Okay, so a piece of wire is cut into two pieces. One piece is bent into a square. Okay, one piece is bent into a square, and the other one an equilateral triangle. Okay, so I'm gonna pick my dimensions carefully. So square is easy, just call it like A, right? This one here, I'm gonna call this 2b, not b, because then this height will be root 3b. Okay. So I want the total area to be a maximum. So first of all, area is a squared plus root 3b squared. If you do this times this, divide by 2. We have two variables. So what do we know about the relationship between a and b? The length, 4a plus 6b is equal to 10. Right? 4a, the perimeter of this is 6b. That's equal to 10. So divide everything by 2. Okay, so 5 minus 2a over 3. So root 3, 5 minus 2a over 3 squared. So this actually turns out, no, okay. I was going to say it turns out nice because it cancels some stuff, but it doesn't. So differentiate this with respect to small a. So this you can actually factor out root 3 over 9 and just differentiate the 5 minus 2a. Like just differentiate this part. Let me write down the next line. And we get 2 5 minus 2a times by minus 2. Set that equal to 0 and solve for a. So we gotta isolate the a, so let's expand. 4 times 5 is 20 over 9 then. 20 over 9 root 3 plus 8 over 9a is equal to 0. Factor out the a. Right, and it's 2 plus 8 over 9, 17 over 9. Oh, I forgot to multiply by root 3 here. So that changes things. If you factor out a, you get 2 plus 8 root 3 over 9a. On the other side, it's going to be 20 over 9 root 3. Let's multiply both sides by 9, and you get 18 plus 8 root 3. There's no a there, right? And here you get 20 root 3. So finally, a is not a nice number. 20 root 3 all over 18 plus 8 root 3. So that's what a should be. So the wires need to be cut this way, right? 4a, and then what is it? 6b, right? So it should be cut so that the first piece is 4 times a, so 4 times this. Right? Therefore, it should be cut. Therefore, it should be cut as 40 root 3, 9 plus 4 root 3 should be one piece. And the other piece will be just 10 minus that.
Aren't there like two parts to the question though? A and B.
Okay. That's what's going to give us maximum. How about minimum? Minimum we're going to obtain by using the endpoints, extreme endpoints. Meaning the entire wire is used to generate a square or triangle. That's going to give you the minimum area. So I know that it's going to be maximum because from here, despite how complicated it looks, it's a quadratic. Look, if you expand this inside, look, this is a 2a. That right there is, or sorry, you gotta look at here. What's the highest power when you expand and everything? 2. So it's gonna be some kind of parabola. Okay. So yeah, so I actually meant minimum, right? So this point right here, because the parabola is going up, the first derivative, the value we got, is giving you this minimum. So for part B, right? For part B, to get the minimum area, you have to pick that A. Okay, you have to cut it like this. Should be for the sum of the area. Minimum. Okay. Okay. For maximum, this is what you do. If you use all squared, basically 4a will be 10, right? So then a will be 5 over 2. So you do 5 over 2 squared, which is 25 over 4. And you also try, okay, what about if it was 6b is equal to 10, so you get b is equal to 5 over 3, right? The area of this is root 3 b squared, so root 3 5 over 3 squared, so that's 25 root 3 over 9. So which one's bigger? So this is bigger. So if you want it to be a minimum, you use the entire 10 meters for, sorry, I guess I said minimum again. For maximum, Agnes, for maximum, you use the entire wire to generate a square.